सर सुपर या बोर्ड पर? Good afternoon, everyone. Hello. I would like to welcome you to the YouTube channel of Chem Academy. Today we are here for the session Chem Academy English. So today we'll be discussing previous year questions of IIT JAM from chemical kinetics. All of you who are new to our channel, quickly subscribe to our channel. Please like this video, share it with your friends so that more and more people can have access to good content. Good afternoon, Kishore. Share it with your friends, ask them to join today's session. So let us begin with the very first question for today. This question came in the IIT JAM exam of 2019. Is the voice okay now? Am I clearly audible? Good afternoon, Meghna. Okay, so the very first question for today is, for a reaction of the type A plus B, it gives products. The unit of the rate constant is mole, liter inverse, second inverse. The overall order of the reaction is. So over here, we are given a particular reaction, which is A plus B, which is getting converted into some products. Now, the unit for the rate constant of this particular reaction has been given over here, which is mole, liter inverse, second inverse. So what have we been asked to calculate over here? We have to calculate the overall order for this reaction. So let us have a look. How do we do that? So we know that the integrated rate equation for nth order is this. I'll show you the more simplified version of this equation. So I will tell you how you must have written this equation. 1 upon n minus 1 into 1 upon concentration of A raised to the power n minus 1 minus 1 upon concentration of A naught raised to the power n minus 1 equals KT. Now this is the integrated rate equation. This is the integrated rate equation for nth order. Now here you can see different places where we have n. Suppose if we have to calculate the value for a particular order, we will just replace n by that order and we will be able to get the integrated rate equation for that particular order. Now over here, yes, good afternoon, Omkar. Share it with your friends and look at this question. So here we will replace whatever value we will replace n with, we will get the integrated rate equation for that particular order. So over here, they have this is just a rearranged form of this equation. So if we have to calculate for a zero order reaction, we will simply replace n with 0. And then we will get this. A equals A naught minus KT. This is what we will get. So if we have to calculate the rate constant, then we will take T in the denominator, and this is how we can calculate the value of K from here. Now, in the question, we have been given the unit of K as mole, liter inverse, and second inverse. How do we determine the order? Since we know that the unit for concentration is mole, liter inverse, and that for time is second, on rearranging this, we will get mole, liter inverse, second inverse. So when we solve this integrated rate equation for nth order, and then when this equation, the value of K is satisfying for 0th order, therefore we can say that, let's go back to the question, that the overall order of the reaction is 0 order. Now this was a long method of doing this question. There is another very simple method of going and doing this question. Yes, all of those who are saying Jyoti, Akash, the correct answer is A. What would be the shortcut method of doing this question? So we can write K as mole, liter inverse, raised to the power 1 minus N, and second inverse. If I open up the brackets, I can simply write it as mole raised to the power 1 minus N and liter raised to the power N minus 1 second inverse. Now this is the general equation that if you will remember, you will be able to find out the order for any given rate constant. Here we have been given this value of rate constant. The K that we have been given is mole, liter inverse, second inverse. So if we have to determine the order by simply equating the standard equation by the given equation, we can determine the order very easily. So let us compare the mole from the standard equation with the given equation. So how can we do that? Mole 1 minus N is equals to mole raised to the power 1. On equating this, we will get 1 minus N equals 1. Therefore, we will get N equals 0. This was the simple method of determining the order for this reaction. Further, to confirm this, we can also equate the value of L here. See, L raised to the power N minus 1 equals L raised to the power minus 1. So we can write it as N minus 1 equals minus 1. Thus, the value of N from here also will be 0. Thus, this is a 0 order reaction. I hope all of you understood this. Now let us go on to the next question. Okay, so the next question is, the half-life of a chemical reaction A, which gives product for initial reactant concentrations of 0.1 and 0.4 mole per liter are 250 seconds respectively. The order of the reaction is. Now again we are given a reaction here. A turns into products. The initial concentrations are 0.1 and 0.4 and their half-lives are 250 seconds. What have we been asked to calculate here? We have to determine the order of this reaction. Let us see how will we determine the order for this reaction. So, as I told you earlier, the general integrated rate equation. So this step we got from the general equation. I will write it again. 1 upon N minus 1 into 1 upon concentration of A raised to the power N minus 1 minus of 1 upon A naught raised to the power N minus 1 equals KT. On rearranging this equation, we will get this. This is just a version of this. You don't have to get confused because of this. So here we knew that for the initial concentration of 0.1, the time was, the half time was 200 seconds. So on substituting these values into the general integrated equation, let us see how we do that. A naught, we will substitute the value of A naught here. Then N minus 1 will remain as it is. We had the half time, so we put the value 200 here, K. How did we get this? Now, how did we get this value of A? Since we have been given half time, therefore the concentration A. Okay, so let me mark it for you over here. This is the initial concentration. This is the initial concentration, and this is concentration after. This is concentration after time t. So concentration after time t, that is half lifetime, will be half of the initial concentration. After putting these values, we will get this equation. Similarly, we had another initial concentration of 0.4. The half lifetime for that was 50 seconds. Again, we will substitute the value in the general equation. Here, we put this value, the value for time, and again here, this is the concentration after half time. So half of 0.4 will be 0.2. We will divide these two equations. We will divide. This is equation 1 and this is equation 2. So on dividing these two equations, we will get equals to 4. And on solving these equations, n equals to 2 will satisfy this equation. Thus, we can say that this is a second order reaction. Now, I will also tell you a simpler way of doing this question. So, since we've been given half-life times in this question, we should know that T half is inversely proportional to A raised to the power n minus 1. You just need to remember this, and a lot of questions will become very, very easy for you. So, half-life is inversely proportional to initial concentration raised to the power order minus 1. N is the order. So, if we use this equation for solving this question, we will easily get the order. Let us see how do we do that. So, we will take 200 divided by 50. We divided the half-life times of the two, which will be equal to, now since this is inversely proportional to the initial concentration, so we know that the initial reaction had half-life time 200. So the initial reaction would come in the denominator, initial concentration, and the initial concentration for 50 seconds will come in the numerator, right? And raised to the power will be n minus 1. Now on solving this, we will get, and on solving this, so from here, you can easily find out, on equating this, you will easily be able to find out the order of the reaction, which will be equals to 2. All right. Now, moving on to the next question. We have a radioactive sample which decays to 10% of its initial concentration. We have a radioactive sample, it decays to 10% of its initial concentration in 4600 minutes. The rate constant of this process is, what do we have to calculate? We have to calculate the rate constant here. Now, one very important thing to remember in this question is, whenever there is mentioned radioactive in the question, it means it is a first order reaction. Radioactive means the reaction is of first order. Let us see how do we do that. So we know that since it is a first order reaction, it is a radioactive reaction, we know that the equation for first order is A equals A naught into e raised to the power lambda t or kt. You can write it either ways. You can also write it as A equals A naught into e raised to the power minus k. Either you can write lambda or you can write k. So it says that, let us go back to the question. It says that a radioactive sample decays to 10% of its initial amount. It means A0 is the initial concentration, and after the decay, it becomes 10% of the initial concentration. So it will become 0.1 A0. So on putting the value of A into the original equation, this is what we will get. Now we will also substitute the value of time over here in this equation. Okay. So this is what we will get. Now we have to get rid of this E. We do not want E in this equation. It is hard to solve E. So we will simply take ln on both sides. We can either take ln or log. If we will take log, then it would become 2.303 log. So here we took ln on both sides. See, E has been removed from here. We got ln 0.1 equals lambda 230 by 3. So to remove ln, we must remember that to remove ln, we will have to convert it into log. We do 2.303 into log. This is how we convert ln to log. So that is what we did. We had ln in the previous step. We multiplied it with 2.303, and then we get log. So on solving this, we can get the value of lambda or the rate constant. What was the important thing that we needed to remember for this? That whenever there is a radioactive sample, it will always be a first order reaction. Moving on to the next question. The time for 50% completion of a zero order reaction is 30 minutes. That it takes 30 minutes for a zero order reaction to get 50% completed. Then the time for 80% completion of this reaction is, we have to find out that. So we have been given that, what all are the things that we have been given? Given that the reaction is of zero order, and since it is getting 50% completed, we can also say that the T half is 30 minutes. This is a T half. So we have to calculate the time when the reaction gets 80% completed. It is very easy. We will first we will use first this information, and we will calculate the rate constant for this reaction. Then we will substitute the value of rate constant and calculate the time for 80% completion. Let us have a look. How do we do this question? So since it is a zero order reaction, this is the integrated rate equation for zero order. We did earlier for nth order. You can simply put value 0, and you will be able to, the value of n, if you put 0, you will be able to get the integrated rate equation for zero order. So here, since the reaction was getting 50% completed, therefore A would be equals to A0 by 2. So here we will substitute A by A0 by 2. So A0 by 2 minus A0 equals minus K, and we can also write T as T half because the reaction was getting 50% completed. Now, on solving this, we will get minus of A0 by 2, but since minus is also on the right hand side, it would get cancelled out. So this was given in the question. This was given in the question. We will put the value of time in this equation, and from here we got the value of K. K has been found from this. Now, since we have determined the value of K, we will simply substitute it in the equation for 80% completion of reaction, and we will calculate the time for that. So suppose the initial amount was 100 and the reaction has been 80% completed, so the remaining amount would be 20. So we know that, what was the equation? A minus A0 equals minus K. So here we will put the value of the remaining amount. This is the initial amount minus K and time of 80% completion. On solving this, and from the previous question, we got the value of K. What was the value of K? Equals A0 upon 16. From the previous question, we got the value of K as A0/60. We have simply substituted this value of K in this equation. From here, we have just simply substituted the value of K over here in this equation. And on solving this, we will finally determine the time T8. Am I not audible? So this is how we found out the time for 80% completion of a reaction when we were given the time for the 50% completion of a reaction after calculating the rate constant. Now moving on to the next question. So this is the question. Now Na24 decays to 1/4 of its initial amount in 29.8 hours. Its decay constant is. So what have we been given in the question? Na decays to 1/4 of its initial amount. So Na has a particular amount and it decays to, it becomes to 1/4 of what we had initially. In what time? In 29.8 hours, it becomes 1/4 of the initial amount. So we have to calculate the decay constant. Remember that we have to convert that decay constant in per hour Indian. Sarji, these questions are the previous year questions of IIT JAM. So let us see how do we do this question. Here again, we did the integrated rate equation for the first order. Again, we will use that equation. A is the concentration after time t. A0 is the initial concentration. What were we given in the question? That it decays to 1/4. That Na24 decays to 1/4 of the initial concentration. So it becomes 1/4 A0. So if we substitute these values in this equation, then A will become A0/4 is equals to A0 e⁻⁻kt. And we were also given the time in the question, that it becomes 1/4 of the initial concentration in how much time? In 29.8 hours. So on solving this, in order to get rid of E, we will take ln on both sides. On taking ln on both sides, let me write it here. Taking ln on both sides. This is what we get here. To solve this, see, I told you earlier also that ln can be converted to log. How will we do this? See, here we've been given ln 1/4 is equals to minus k into 29.8. So we can convert this by 2.303 log of 1/4 equals minus k into 29.8. So in order to solve this, we can do 2.303 log 1 minus of log 4 equals minus k into 29.8. So we know that the value of log 1 is 0. This can be written as log 2 log 2. On solving this, we will get this value of rate constant, and we have determined it in per hour as we were asked to do in the question. Kishore, these are the previous year questions of IIT JAM. Today we are only going to discuss the previous year questions of IIT JAM. Now, coming to the next question, we have this question over here. For a first order reaction, we have been given in the question itself that this reaction is of the very first order. For the first order reaction, A gives 2B plus C, all are in gaseous states. The rate constant in terms of initial pressure P0 and pressure at time t Pt is given by. Now we have been given a first order reaction and we have to calculate the rate in terms of the initial pressure and pressure at time t. First of all, we will do this question. I will tell you how to do this question by a conventional method. Then I'm going to give you a shortcut method which will give you your answer in literally 20 seconds. So let us look at the conventional method of doing this question. See, so here, this is the equation that we've been given in the question. Now, at time t, the pressure of A was P0 at time t equals 0. But at some time t, after some time has passed, the pressure became P0 minus P. The pressure of B is 2P and the pressure of C is P. Now, if we have to calculate the total pressure, we will just add all of these. See, that's exactly what we did. P0 minus P plus 2P C. This 2P from here and this P we got from here. We just simply added these and we got P0 plus 2P. From here we got the value of P. This is the value of P. Now moving on, we will substitute the value of P in the equation, and upon solving this, we will get this. Now, this was a very long method. You will have to systematically go on doing it from the very beginning, solving each and every step. Now, there is a very short method of also solving this question. If you have been given a particular equation where all the constituents, all the species are in gaseous state, and you have to and it has been mentioned that it is a first order reaction, and you have to calculate the rate constant in terms of pressure, then a simple method of doing it is, you can remember this. So it will be K equals 2.303 upon T log of, this is a simple method of doing it. So it will become summation of stoichiometry. Summation of stoichiometry of products minus reactants into P0. This will be divided by summation of stoichiometry of product into P0 minus summation of stoichiometry of reactants into PT. Okay, so this is a simple method of doing this. Now let us try to solve this question using this method. So 2.303 log can also be written as ln. So I can write it as K equals ln upon P, the stoichiometry of products minus reactant. So here it is 2 plus 1, 3. This is the stoichiometry of products. It will be 3 and the stoichiometry of reactant is 1. So 3 minus 1 we will get 2 P0 divided by the stoichiometry of products into P0. What is the stoichiometry of products here? It is 3. So it will become 3 into P naught minus stoichiometry of reactants into PT. The stoichiometry of reactant here is 1. So it will become 1 into PT. I don't have to write it. So the correct answer, you can easily see here, the correct answer would be B. Yes, Chandra Mohan, you're correct. The correct answer is B. Ashish Bora, correct. B option is the correct answer. I hope all of you were able to understand this question. This method would help you find out the answer to questions like these very easily. You would not have to go to that entire method, which is very long and tedious. Now moving on to the next question. Now, here a radioactive element undergoes 80% radioactive decay in 300 minutes. The half-life for the species in minutes is, since again radioactive, as I told you earlier, radioactive means first order. Radioactive means first order. So let us see how to do this question. So this is the method we can determine the rate constant using this formula. So I'll tell you what this formula exactly is. It is K equals 2.303 divided by T into log of A naught upon A. Or it can also be written as K equals 2.303 by T into log of A upon A minus X. These are all the same. Now here, this is the initial concentration. This A represents the initial concentration and this represents the concentration after time t. Okay. So if we put these values in this equation, we will be able to determine the values very easily. So what were we given in the question? It goes 80% decay in 300 minutes. So first of all, we will determine the value of K from this equation. 2.303 time was given, 300 we have just substituted the value into log of 100 upon 20. 20 because 80% reaction was completed. If initially we had 100 and reaction was 80% completed, what was the remaining amount? What was the remaining reaction? It was 20%. So we will take 20 in the denominator. From here, we have calculated the value of K. This is the value of K. So if we have to determine the value of half-life, we know that T half for a first order reaction is T half equals 0.693 by K. So we will substitute this value of K in this equation and we will calculate the value of T half very, very easily, and this would be the final answer. Okay. So moving on to the next question. Now here it says that for a zero order reaction, the half-life depends on the initial concentration C0 of the reactant as. We are told that it is a zero order reaction. We have to find out the half-life on the initial concentration C0. How does it depend on C0? So as I told you earlier also in one of the questions that T half, that half-life is inversely proportional to initial concentration raised to the power n minus 1. Okay. So since it is zero order, we will take the value of n to be 0. So it will become C naught raised to the power minus 1. So to remove this minus, we will take it to the numerator. So it will become C naught. So therefore, we can easily say that 𝑇12 is directly proportional to C naught. So the correct answer would be option number A. Yes, Pratibha, very good. The correct answer is A. Here is the justification of it. As I told you, 𝑇12 is inversely proportional to initial concentration raised to the power n minus 1. We can just substitute the value of n with the given order in the question, and we will be able to determine the relationship between them. If you have not subscribed to our channel yet, please subscribe to our channel, like this video and share it with your friends. Now, the next question is, the kinetics of the reaction 2N2O5, it gives 4NO2 plus O2 in liquid bromine medium was measured independently for 3 initial concentrations. We've been given 3 initial concentrations. Okay, the half-life of the reaction was found to be, this is the half-life. The half-life of the reaction was found to be 4.5 hours for all of these concentrations. The order of the reaction is. Now, this question might look very difficult, but actually this is probably the easiest question today. See, here we have been given 3 initial concentrations, but all of them have the same half-life. Okay, so what did we just study? We just studied that 𝑇12 is inversely proportional to initial concentration raised to the power n minus 1. So now, if I take the value of n equals 1, what will happen? If I take the value of n equals 1, A0 would become, it would become A0 raised to the power 0. So I'll say if n equals 1. Okay, if I'll take n equals 1 here, it would become A0 1 minus 1. It would become A0 raised to the power 0. It means that the half-life would become independent of the initial concentration. If the power of A0 will become 0, then the half-lifetime would become independent of the initial concentration. And that is exactly what is the situation in this particular question. Here the initial concentrations are different, but the half-life is same. There is no change in half-life. It is constant. It is constantly coming out to be 4.5 hours. Therefore, since the half-life is independent of the initial concentration, we can say that the order of reaction is 1. Yes. Very good, Pratibha. Very good, Rashika. The correct answer is B part. Suppose, now moving on to the next question. We have a wood specimen. Suppose the question is, a wood specimen containing 14C taken from an ancient palace showed 24 counts in 3 minutes per gram of carbon in a detector. However, a fresh wood showed 52 counts in 2 minutes per gram of carbon. Assuming no background signal in the detector, the half-life of 14C as 5730 years, the age of wood specimen is. So what have you been given? When C14 was taken from an ancient palace, it was 24 counts per 3 minutes. When it was fresh wood, then it showed 52 counts in 2 minutes. So when it has a half-life of 5730 years, we have to calculate the age of the wood specimen. Let us see how do we do this question. So this question can be easily solved by this particular formula. We have done this earlier. I will show you the simplified version. It can be written as K equals 2.303 by T log of activity of fresh sample divided by activity of dead sample. Now, if we have to change this 2.303 log, this will convert into ln. So if you have ln in the question, you can simply multiply it by 2.303. So on substituting the values, we can calculate the value of t. Now, over here, how do we find the value of k? We have been given, we know that t half for a first order reaction equals 0.693 by k. Okay, and we are already given the half-life. From here, we can calculate the value of k, and we can substitute this value of k in this equation, and we can easily calculate the value of time. We will be able to easily calculate the value of this time. I hope it is clear. This was the question, and this is how we did it. Now, moving on to the next question. Now here, for a reaction, the rate constant at 25 degrees Celsius is doubled when the temperature is raised to 45 degrees Celsius. The activation energy in kilojoule per mole of the reaction is. Now, this question can be solved with the help of integrated Arrhenius equation. Okay, we can easily solve this with the help of integrated Arrhenius equation. Let us see how will we do that. This is integrated Arrhenius equation. This is actually R. This is the gas constant. So here, this is integrated Arrhenius equation. Ln K2 by K1 equals, this is activation energy this is the activation energy into T2 minus T1 upon T1 T2. Now, the initial temperature that we were given was T1 was 25 degrees Celsius plus 273. We will only use the value of temperature in Kelvin. We will only use the value in Kelvin. It will become 298 Kelvin. It says that the temperature is raised to 45 degrees Celsius. It is not saying raised by. You will have to be very careful when it says by and when it says to. Here it is not by, it is to. So actually the change in temperature is only of 20 degrees. So T2 would become, T2 is actually 298 plus 20. That is because the difference between the two is only 20 degrees Celsius. So this would become 318 Kelvin. We have gotten the values of T1 and T2. Now we will substitute the values of T1 and T2 in this equation, and we will be able to get the value of activation energy. Also, it said, the simplified version, I'll show you how to do it. It said that on raising the temperature, the value of rate constant becomes 2 times. So it is actually T2 minus T1 means minus 298 divided by 318 into 298. And you can further solve it by putting in the values. This is how to solve this question. Now moving on to the next question. Suppose we have this particular reaction, 2NO plus 2H2. It gives us N2 plus 2H2O. We have to write the rate of reaction in terms of change in concentration of NO and H2O. How do we write the rate expression for this reaction. It is very simple to write it. We can write it as rate equals minus of 1/2 dNO upon dt equals to minus 1/2 dH2 upon dt. It is equals to dN2 upon dt is equals to 1/2 dH2O upon dt. So this is how we can write the rate expression for this equation, and we have to write the expression for rate in terms of NO and H2O. So this is for NO and this is for H2O. See, this is how we have done it. This is the entire rate expression and this is for NO and H2O. Now moving to the second part of the question, it says, now given the following data for the above reaction, find the order of the reaction with respect to A, NO and B, H2 and the rate constant of the given reaction with proper unit. Now we have to find out the order of reaction with respect to NO and H2. How do we do that? Now first of all, to find out the order with respect to NO, we will find two such values of H2 where it is constant. Now here we can see that H2 is constant here and here, and on going from this to this value is actually getting doubled. If we multiply it by 2, then we will get this value, and over here this is actually 4 times. So from here what we can conclude that on keeping the value of H2 constant, if NO is getting doubled, then the initial rate is becoming 4 times. If NO is getting doubled and initial rate is becoming 4 times, it means that the reaction is second order with respect to NO. Okay, we are going, if we double the amount of NO on keeping H2 constant, then the initial rate is becoming 4 times. It means that the reaction is second order with respect to NO. Now, if we have to calculate the order of reaction with respect to H2, we will find 2 values of NO where it is constant. I will change the color of the pen. See, now we will take 2 values of NO where it is constant. It is constant here and here. Now to calculate H2, if we go from here to here, the value is getting doubled. And if we go from here to here, the rate is also getting doubled. So what do we conclude from this? On keeping the value of NO constant, if the concentration of H2 is getting doubled, then the initial rate is also getting doubled. On keeping the concentration of NO constant, H2 is getting doubled, initial rate is also getting doubled. It means with respect to H2, the reaction is first order. Is it clear? So reaction is second order with respect to NO and first order with respect to H2. Okay, and we also have to find the rate constant for the reaction. Last part of the question is remaining, which is we have to find out the rate constant for this reaction. Let us see how to do that. So if we have to write the rate expression for this reaction, we can write it like this. Rate equals K into concentration of NO. We found out that it is second order with respect to NO. So we will write 2 in the power, and it was first order with respect to H2. So here is simply 1 in the power. Now we will substitute the values from experiment 1 in this equation. See, this is experiment 1. We will substitute the value of NO, the value of H2, and the value of rate in the equation. See, this is the value of rate that we substituted from experiment 1. This is the value of NO that we substituted from experiment 1. And this is the value of H2 that we will substitute from experiment 1. and we can easily determine the value of K from the equation. Okay, is it clear? I hope you all have understood what I explained. Thank you so much for joining today's session. I hope you all enjoyed the session. If you haven't subscribed to our channel yet, please subscribe to our channel, hit that bell icon, like this video and share it with your friends so that they can also practice and get to learn the previous year questions from IIT JAM. So upon these questions are the previous year questions from IIT JAM. These are not net and gate questions. These are the previous year questions of IIT JAM. Thank you so much for joining today's session. Stay home, stay safe.